In a previous unit, we spent a lot of time graphing and talking about parabolas, so I'm just going to quickly remind you of some information. So when you see parabola, you want to think about a graph that has a U-shape opening up or a U-shape opening down. And that will be based on the A value. So this value right here in front, if it's positive, will open up. If it's a little negative, as in number 13, the graph will open down. When you're making an in-out table with your function, your normal x value inputs can be positive or negative, and your y values are always positive. So with parabolas, I'm just going to put a couple of coordinates here to get our general graph. We're going to use -3, 2, and 1, 0, 1, 2, 3. Those are the standard that we use. As you can see on the graphs that we're making available here, the graph does not go all the way out past 6, so some of these coordinates we're not going to be able to plot. But with a parabola, your standard function is y equals x squared. So when you plug in a negative and square it, it becomes positive. Right? So all of these -2 squared, -1 squared, and then again when you square positives, they also stay positive. So you can see that on our table, when we graph, if our graph is big enough to include these numbers, we will, but for most of what we're going to do today, we won't be using these when we plot points today. We'll just focus on those few. All right, so standard form of a quadratic, again, is y equals a times x minus h quantity squared plus k. All right, again, as always, attached to the x is your left-right shift, what we call our horizontal translation, and k is your vertical. So your vertex is the value hk. What we call our line of symmetry, which cuts our graph exactly in half, is what happens at x equals h. Your zeros are your places they cross the x-axis, so we'll get to that in a second. So let's look at a few examples here of how some of this is going to work. We'll start off with number 11. All right, your vertex, because your vertex is that coordinate hk, that means that my vertex here is going to be the coordinate -3, -4. So you need to remember that your h is always the opposite of what you currently see. K is exactly the way it is. My line of symmetry is x equals -3. It's a vertical line that cuts my graph in half, and it goes right through the vertex. Your shifts, this is your horizontal and vertical translation. So that means that horizontally, I went left 3, and then I'm going to go down 4. So in some of your assignments, it will say shifts. Sometimes it will say translations. Same thing. So I'm going to make my graph. And since this has a shift to it, I need to think about how I'm going to change all of these coordinates. And so I'm going to make a little quick in-out table onto the side here. All right. So my x, I'm going to have to move all of my x's to the left by 3. And these shifts will help you in creating your in-out table. And to all the y values, I need to move down by 4. Right. And so my normal x values, right, and then I'm going to have to subtract off 3 from all of these. And so that's going to make my new x coordinate -5, right, -4, -3, and so on. Right. Same thing with my y's. My output was regularly 4, 1, 0, 1, and 2, or sorry, 1 and 4. So take 4 away from all of these. And you can start getting your new coordinates. And so, again, hopefully you can see your table a little bit better than mine, but this is a coordinate. Right? -4, -3 is a coordinate. Right? So I've got some coordinates here. Right? So I'm going to plot those. So at -5, 0, -4, -3, all right, and so on. So you can start seeing that there is a pattern in how we do this. And so then my graph is going to move up. Right. And on this right-hand side, I do have a lot more coordinates. So if I wanted to, I could make just one more and say when x was 3. All right, so my normal y output when I square 3 is 9, and I can get 5. So I actually have another coordinate here that is useful. And so we've got a couple things. These 2 coordinates right here where my graph crosses the x-axis are my zeros. So at -5 and 0, and -1 and 0. Those are called my zeros, or they're also called x-intercepts. And even though it's not one of my lines here, if I fill in the blanks, this coordinate right here is my y-intercept. So I'm just going to write that down for future. That my y-intercept is the coordinate 0, 5. So this is how we want to be able to graph our equations for parabolas when they're in this vertex form. All right, so let's look at another one. So again, my vertex is HK. In this case, it's going to be 1, 2. My line of symmetry is at x equals 1. Oh, let me go back here real quick. The line of symmetry, this x equals -3. This is a vertical line that goes through my graph. It goes through the vertex, and it cuts my graph into 2 equal portions. And so I labeled what it was up here, but I didn't actually draw it in. I'd like you to see that that's an invisible vertical line. Same thing over here. I will end up having an invisible vertical line of symmetry going through x equals 1. Don't make that solid. It's invisible. So my shifts, I'm going to need to go up 2. I also need to go right 1. And the dilation, this is based off of your A value. All right? And what that's saying is your dilation is 1/2, meaning that it's going to take my graph half as long, or twice as long to get to where it needs to go, because it's going to only increase by half the distance. So I need another little in-out table. And so to my x's, I am going to have to add 1 to all of my x values. But to my y values, I need to first cut it in half before I add 2. And so again, if you think about your x values, all right, I'm going to try to give myself a little more space this time. I need to add 1 to all of those. So my new x value is going to be at -1, 0, 1, 2, and 3. Now my y values, I need to take half of my current output and then add 2. So half of 4 is 2, and 2 plus 2 is 4. So you can do this on your calculator. You can do a little bit of mental math. I also need to take half of 1 and then add 2. Well, that's going to be a half, and so my new coordinate is going to be at 2.5. And so on. Half of 0 plus 2 makes my new coordinate at 2. When I take half of 1 again and add 2, again, that's going to be a 2.5. And so on. I should get back up to where I started. So I'm going to put a coordinate at -1, +4, at 0, 2.5, at 1, 2, at 2 and 2.5, again, and at 3 and 4. All right, so this is my graph. All right, so 5 points is good. And so you can just see that it's opening up wider. It's the dilation spreads out the graph a little bit more. All right, so both of those were parabolas opening up. So this parabola opens down. However, that does not change the vertex. Even though there's no parentheses here, that's the same thing as if I wrote a negative x plus 0 squared plus 5, plus 5. So if there's no parentheses, that just means you don't have a left or right shift. Your vertex is going to be at 0 and 5 because this is just shifting up. My line of symmetry runs through the h value, which is still 0. And I only have one shift. This only means that I went up by 5. And now what happens is it's asking this question, max or min. And what that is it's saying that our vertex creates a maximum or a minimum value. All right, here the vertex is creating a minimum. And here the vertex is creating a maximum. It's the highest or lowest point of a graph. All right. And so with this, I'm going to say that I have a max, right, because my graph is going to open down like this. And my maximum of that value is going to be here at the vertex at 5. Right. I'm sorry, that's what it is. It's not at 5. It's at 0. It's the x-coordinate of where it appears. So my line of symmetry runs through the y-axis. Okay. And this is my vertex. And now with my input-output table, my x values didn't change, just the y values. And so when I look at these, all these x values that I normally am using for -2, -1, 0, 1, and 2, those don't change. But I need to take a negative times my output and then add 5. So my normal output would be 4, so I need -4 plus 5, which is 1. So what's going to happen is at -2, I'm at +1. This normal output is 1, but that would be -1 plus 5, right, which is 4. Or 0 plus 5, which is 5, and it's already on there. And you can see the pattern's going to repeat again. And then again, this is going to be -5, or -4 plus 5, which is 1. So you can see now with a negative, the graph opens down. And so that's just a little bit of general graphing and going on the side with some of these vertexes and line of symmetries and pieces of information that we haven't talked about in a while.